Okay, so we've got the D-TEK Pro here. So we're at 240 something, and that's with it sitting there with the unit not running. Oh, I think she just shut off. That's nice.
This video is brought to you in part by TruTech Tools. Quality tools, essential support.
All right, guys, let's go in here. We're going to work on a air dryer. This is one of them things where, you know, we don't do that every day, but guess what? It's refrigeration. Refrigeration works the same way. Now, I did put my reflective vest on here because these guys are driving around, so for my safety, I'm putting it on, help protect myself from getting ran over. So what we've got here is a dryer. Over there is the compressor, and here is the tanks for it, okay? That's your storage tank. So the maintenance guys told me it blew a fuse, they reset it, and it started to run. Now, what we did notice when we were looking inside here is we've got oil, but it could be just regular oil. I thought maybe we had an issue with that. So what I'm gonna do right off the bat, we've verified that let's check in for oil to see if we got leaks here or what. You gotta remember, it's really oil from the manufacturing. They've got a lot of manufacturing going on over there. So what we got is an actual real Megger, not that Supco thing. It's an X-TEK. It's not as expensive as Fluke, but they're a well-respected brand. And depending on the voltage of this, we're gonna go usually double of whatever it's rated at. So if this is a 460 volt, we'll go 1,000. If it's 208 volt, we'll go 500. So basically a place that takes care of these doesn't have a refrigeration guy, so when they find an issue, they call us to do that. Otherwise, another company takes care of all the maintenance as far as filters and tune-up kits and all that stuff. The way this thing works is the compressor's right here. You got your regular refrigeration system. So right here we have an oil separator, and what that does is the discharge gas comes into here, and then it falls down to the bottom and gets sucked up into the suction line and back to the compressor. Comes discharge gas in, comes out, goes to the condenser, comes out of the condenser, comes to a filter dryer right here, up over to a SAV, which is probably like a set expansion valve, and then you have another one here which is coming off the discharge. So that's going to keep your minimum pressure, almost like an EPR, so you're going to keep your minimum pressure. And it goes through there and comes out the other side. And basically the heat exchanger, yeah, here's the suction coming back. So all you got is your regular components. Compressor, condenser, evaporator, add a separator in there, add a dryer, add a metering device. It's the same loop over and over. I've never worked on this particular this machine ever, but that doesn't stop me from tearing into it and figuring out what's wrong with it, because we understand the basics of how this thing works. You got a high pressure, low pressure, and a fan control most likely, FP. These flare joints, you know, we always have possible leaks on those, but we need to find out why that thing tripped and why it's not working. So first thing I'm gonna do is isolate this thing, and we're gonna find out if you got a bad compressor. There we go. Okay, let's check for voltage, which this has got basic voltage on it, 750 volt range. We can go just to ground's fine for now. Tap on it, make sure we have nothing on there, nothing there, nothing there. So we're good there on that. Now, when you do this, I like to isolate the terminals, or while we're at it, we're gonna check and make sure that we don't have any terminals that are shoddy. So let's go ahead and yank them terminals off, make sure that they're not, because you don't want to ohm or meg out a compressor when you might possibly have a bad wire down here. There's nothing worse than doing something like that and then condemning it, and then you get the new compressor in there and it still don't fix the problem because you didn't do your due diligence to isolate it properly. Now you gotta remember, you could have refrigerant in here, so we come down here, we can clamp onto one of the terminals, let's put it on Megger, and the voltage on this, 480 volts, so let's go ahead and do 1,000 volts here. So 1,000 volts, we'll hit test. They're still putting out 1,000 volts. The mega ohm reading went up. That could be moisture. Yeah, so I'm not too horribly concerned there. Let's go to the next one, and technically you can hook them all together. We're keeping everything isolated. We're on the copper side over here of the compressor. Test again. Good on that one. So we know that we probably don't have a shorted compressor. So resistance on ohms is not going to be, it's going to be very low voltage. That's why your ohm meter doesn't do very good. This is actually generating voltage, stepping it up. It's nothing on ohms. You can check regular resistance. We can go from terminal to terminal. So we got 1.9 ohms there. 1.9 ohms there. Switch positions here at this one. Move it over. 1.9, 1.9. So we know that our resistances between all of our leads is the same because this is three-phase. That's normal. It's usually going to be really low resistance when it's three-phase, and because it has the torque from the phasing automatically hitting it. 1, 2, 3, 1, 2, 3, 1, 2, 3, boom, boom, boom. There's no phase shift or anything like that that has to be done. Okay, we got that in there. We got that rubber grommet back in there. That's who makes it, Advanced Scroll, I guess. Okay, so we've got the D-TEK Pro here. I showed this in one of my other videos. I got this just for a short period of time, maybe a week or 2, 3, whatever. And we're checking for the leak. This is their latest and greatest. It's not quite out yet, but I know one person told me that it's supposedly on pre-sale at TruTech Tools. All right, let's see what we can find here. So we've got it going down here. Let's start scanning around and see if we can find anything. We're gonna follow the pipes all the way around. If it never fails, you could have a crack in the middle of a pipe. Could be in the terminal strips of the compressor. Could be any one of the many different terminals or brace joints. So we're gonna scan this whole thing over piece by piece. And the pump on this thing is super, super fast. It's 10 times more powerful than the Stratus or the D-TEK 3. And so we're looking to see if we've got any leaks at all in here. That oil could be easily from the air compressors, may not be from this, but we're just gonna, before we get too big in deal into it, let's make, looky there, what do we got going on? We just had a peek of something. Oil does not appear to be picking up anything. So we got something going on over there. We'll dig into that. Let's make sure we ain't got nothing over here. I have a feeling it's probably low on charge. It got real super hot's one of the things he said too. It was like going off on thermal overload. And these have a lot of vibration sometimes, depending on what's going on in this factory. 9, we gotta be getting close. This was not very easy to figure out because the way they got it designed in here kind of stinks. But you've got some screws around the edge corners here. You've got to take off 3 screws across the bottom. All right, so here's where we're at. We're on the front of it. Utilizing my Klein knee pads here from TruTech Tools. These hinge at the top. You know, these weren't real cheap. They're about 40 bucks, but neither is knee surgery or quitting work early or going to a desk job because you can't walk anymore. It's really important, young guys. Keep your knees protected. I surprisingly am not having any problems yet, even at 50. All right, so I think we found what was going on here. If we come down here to this spot right here, on that one there, she does not like it. Let's see if it'll do it again. Nope, it's that one. All right, so we're at 240 something, and that's with it sitting there with the unit not running. Can you imagine, since that's discharge gas pressure, highest that it can do at 407C, probably a couple 100 pounds of pressure, it's gonna leak really fast. Now we went through here, we looked at some of these other ones. We're not picking up anything down here when we go on the bottom of the coil like this. We're pretty much dead. Now, you're wondering, okay, like I said, even though this is a air dryer, it's still a refrigeration system. We're running drying air. It's the same thing. We basically got ourselves a dehumidifier here. The plate gets cold, the hot air goes through it, it hits it, condensates, drips to the bottom. They got timers on it. It accumulates, hits a sensor, blows the moisture out, and it separates it right there. So yeah, that's basically what we've got. All right, let's find out how well this thing did. That bad boy can hardly even be seen. That's the leak. Microscopic pinhole. That's crazy. Well, that definitely is going to leave us low. So I would not be surprised this thing's low. I haven't even checked it yet because, like I said, well, as I told first, I had a blown fuse, that it tripped the fuse, then that it's getting overheated. So we made sure the compressor was dead, because if the compressor's dead, job's done. Deal with stuff later. Found out that wasn't bad. Then we went on to what would cause it to overheat. Lack of refrigerant. Boom, found a leak. Now it's a matter of fixing the leak, which we'll have to recover it and recharge it. It's 407C. Just boom, 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 boom. Order operation. Keep it simple, stupid, and work your way down. All right, so the customer, I called him, told him what we had, and he approved fixing the leak, so we got to recover it if I can get this dang valve core out. So it holds 10 pounds. This was built in 21. Oh, look at that. It's kind of bent a little bit. Well, that's junk, ain't it? Do some 3/8 hose here. I got some 1/2-inch hoses. I only have one 1/2-inch hose. The other one hasn't came yet, which it might have got delivered today. I'll tell you what, we'll just do 3/8 today. But I got adapters to go from 3/8 to 1/2-inch. And if you understand how the vacuum works with the friction loss of the hoses, that makes a huge difference. Even though we're going out of the 1/4 inch, once it gets around it, it accumulates. I don't fully 100% understand it because it's some sort of science crap. But either way, it allows you to get the job done faster, and that's all I really need to know. So we're going to go ahead and give this thing an old suckaroo and get on down to repairing it. I am so glad there's a guardrail there. Somebody so nicely parked a forklift right there in the way, so they're all coming through here at 100 mile an hour. We're going to experiment a little bit. My thought is any restriction that's in that liquid could act like an orifice and actually cool the tank down a little bit. But I love that. That machine is really awesome. It still has a little bit of an issue with 410A, but that's not too uncommon. I think my Inficon might have done better with 410A, but this is so much smaller, and it has nicer gauges. Now the thought process also behind this is we're pulling off the liquid line here. Moving liquid is the fastest way to move the refrigerant. Then after that, it's just all sucking vapor, which takes forever. All right, so we've got the wire brush in my drill. I should, before using this on cleaning up real contaminated copper. I went out looking for my flux because I couldn't find it, and it was right over my head, so I'm losing my mind. Just use that to kind of help keep it clean. If it does remelt there on the other side, I want to keep it happy. Let's go ahead and get in here and get her. Try not to melt some wires while we're at her, right? Okay, let's go ahead and get this heated up. Once we get her liquidy, like it already is, we'll add just a little bit to it. Try to get the heat on both of them, bring it around. Probably got them both. I'd like to be able to get that back side a little better. There we go. I think we're good. There we go, all beautiful. There we go. I believe we got it. What do you guys think? We got a little extra on that. Don't look too bad. I've seen better, but looks better now. You got some of the goobers off of it. There's a couple little sprinkles there, but I think that's from some things falling down. Okay, we just went ahead and weighed the tank. It's 38.4. I don't know if that's from the old stuff in the tank. That's why I hate reusing tanks. Those things, you know, they got burnouts in them, and you know, you can use a dip tube so the crap hopefully falls to the bottom, but you can put a filter dryer on it, which is probably what I'll do, but it's not a good idea. But it's also 10 pounds, you know, it's 400 bucks, 450 bucks, whatever. Depends on what refrigerant, so I don't know. I guess we'll just put a filter on it and go from there. So we've got the vacuum hoses going on. I've got the micron gauge getting started here. Using the JB, I had to throw some more oil in it from last weekend, or last week on Friday when I dumped the oil in that last video. Check that out, link up above. All right, so we got her down to 315 microns, 311. Let's go ahead and valve off and see if it holds and kind of go from there. You can see it's already jumping like crazy. Okay, we're kind of slowing down, but we're kind of getting up there. As long as it slows down, we know it's not a leak. If it keeps on going, we know it's either refrigerant boiling off or potentially moisture. But the leak rate right here tells you everything you need to know. Otherwise, those numbers just look like they're flying. There's 1.5. All right, so we shut off about 1,000 microns, and it's stopping. So I'm good with that. So we just zeroed down our recovery tank. We got it on there, going through a 1/4 inch brand new filter dryer. Bled all the way up to our core tool. We're gonna dump some in here and we'll double check it for leaks, just to make certain. But we'll throw a pound in there and see where that puts us at, and then we'll scan it with the leak detector just to make sure we got it. I just scanned it, but for record and show. We were pegging out really good before, and right now we are at 0. Nothing. And we are valved off. All right, so we got a new valve core. We're gonna put that in a suction side while we're finishing dumping in our refrigerant. So far we're at 6.5 pounds. I think these are probably not working with these valve core tools. That might be why they got bent. The stem on these is a little longer than what the original one was. And that might be what's going on there. I might have a messed up seal. Looks like the rubber's a little messed up. So that is one thing you got to watch is are your valve core tools leaking? That's why I've got so many of them, because when it comes to evacuation, you really need good seals, and sometimes replacing the seals is more work than it is just to replace the tool. A lot of times it never seems to reseal very well later. Well, we're almost 8 pounds and we're at about 14 pounds of pressure. So I'm going to say 8 pounds is where we're going to probably stop at here. And then we'll weigh in the other 2 pounds. Ugh. As soon as we get this on, we got to put the cover on so we can run it. Alrighty, so 10.12 is what we got. All right, good to go. Well, let's put the fuses in, make this thing roll. One of the things you got to notice, these fuses, they look like they've been pulled and pushed back in 300 times. I'm sure when they blow them, they probably replaced just one, not all of them. And it very likely could have been pulled out of another machine. Let's look at the amp draw on this. Okay, we're trying to get it to turn on. That don't feel right. I don't feel, yeah, there we go. We got power back there. Okay, that's a timer circuit. All right, so I have no display down here. That thing down there, light on it, that is a phase protector or phase rotation device that makes sure that it's the right phasing. I'm assuming it probably does battery or voltage also. 487. 484, 483. So we're good there. Okay, so what we had, it just kicked on. 75-pound suction. Let's go ahead and get this last ounce in here. Until already that fan's not coming on. Look at that. 340. Are we going to trip out on the head pressure control again? What's going on here? Going higher and higher. Okay, I'm not seeing the fan kick on. That's probably why it tripped. Wouldn't that suck? So we also got an issue with, yeah, 335, and it's still not coming on. Well, that suck. We got a problem with the fan too on top of everything. So let's go ahead and get, I really like to dump the rest of this refrigerant in here. Oh, I think she just shut off. That's nice. All right, well, anyhow, the high pressure switch here was tripped down here on bottom. Is why it wasn't wanting to come on. So the wire comes down, comes around, connects at the bottom of the contactor with the compressor. It should be running. So I bet we have a bad fan. We'll double check voltage there, but I mean, it's pretty cut and dry. But it's a weird fan, so we don't have one of these obviously around here. So that'll need to be ordered. That's some weird wang dang dong thing here. Yep. Okay, so I've already checked to make sure I got voltage to my fans. We're gonna go ahead and unhook it and we're gonna check resistance. See what we got here now. Between here and here. 1 mega ohm. Here and here, 1.4 mega ohm. I bet you that's where that voltage issue or that trip breaker fuse came from. There you go. That's the fan motor blew up, and then you had a leak on top of that, and you were 2 pounds low. Because they would have noticed the fan not running. So it's obviously a combination of 2 different things. You're low on charge, and the fan motor is bad. Imagine that, right? Anyhow, just gonna wrap this one up. I'll go ahead and pump the rest of the refrigerant in. See whether or not I get back. May not. Maybe somebody else. All right, it's just one of those calls. The fan motor's bad. I didn't do anything wrong by fixing a leak or doing anything, weighing the charge in, because obviously we were low on charge, and that was an issue. We'll have to order a motor. Hopefully I'll be the one come back to do it. If not, I guess we'll deal with that then. But if not, that's what we had going on, and that's how I diagnosed it and how I came up with what I came up with. Hope you guys enjoyed the video. If you did, please go ahead and smack that like button. Leave me a comment down below. Consider subscribing if you haven't already. And until next time, we'll catch you guys on the next one. Thanks for watching. Later.